to determine if I have a linear or nonlinear function. Looking at our first table here, which is miles driven and state line crossed. The first thing I want to do is figure out what the change is over the x's. So if I have 40 going to 120, that's a change of 80. From 120 to 160, a change of 40. We then are going to look at state line crossed, which is my y variable. From a 1 to a 0 is a change of -1, and a 0 to 1, change of +1. So if I was to look to see if there is going to be a linear relationship, I'm going to take the y change and put it over the x change. So here I'd have -1 over 80. For the second piece of information I'm given, it'd be 1 over 40. These are not the same, so it's not going to be a linear function. Let's look at the second example. I'm going to look at hamburgers ordered versus the cost. So hamburgers ordered from 1 to 2, a change of 1. From 2 to 3, a change of 1. Cost from 4 to 8, a change of 4. 8 to 12, 4. And again, I'm going to look to see my cost over the hamburgers ordered. So here I'll have 4 over 1, and on the second piece of information, 4 over 1, and they equal each other. So yes, this is going to be a linear function, and I'm going to have that rate of change as 4. So to write an equation, I would write that y equals 4x. If I was asked to graph this, here's my y-axis, here's my x-axis. My x, I have to graph 1, 2, 3, so we're just going to go by ones here. 1, 2, 3. But my y-axis, I have 4, 8, 12. Maybe I want to go by 2's here on the number line. So maybe 2, 4, 6, 8, 10, and then 12. And I would plot the points. So my x variable is 1, my y is 4. So 1, 4. 2, 8, and then 3, 12. And if you notice, we do have this nice linear relationship happening for this table that I could sketch in here. So what we wanted to do, again, is to compare how the y's are changing over how the x's are changing. And if we end up with that same ratio, that same number here, then yes, it will be linear.